Hi, it's Matthew Reed from Reed Repairs and welcome to the 9th and concluding part of our series on repairing this 3-train 18th century spring clock. Today we're going to tie up the final few repairs, we're going to clean the clock, put it together, lubricate it, fit new gut lines on the fusees and of course get it on test. So please enjoy, don't forget to like and subscribe, and we will see you in a short while. So in concluding our relatively minor repairs to this clock, first I check all the mating mobiles for depthing or optimal mesh. If the mobiles are not optimally depthed, too far apart, or unusually too close together, we may want to consider moving one or more bearings, a process that is typically called bushing or rebushing. During this process, I noticed the intermediate or third wheel of the going train was wobbling on its arbor. This is caused by a common misconception that if a pinion, the small driven steel gear, appears worn, the wheel should be moved on its arbor to unworn piece of pinion. This involves heating the collet, the brass boss on which the wheel is fitted, which softens the soft solder that holds it in place and shifting the wheel along the arbor slightly. Regrettably, as in this case, this process tends to cause more trouble than it resolves, and once the collet is moved, it can't easily be undone because concentricity is lost, and concentricity is fairly critical to our train working properly. And here, as evidence, we can see soft solder that was once under the collet is now exposed. So I decide to re-collet the wheel, which will gain us back some concentricity and flatness or trueness. Regrettably, this means the existing collet will be lost, which is a shame, but we want to restore function. So I begin by removing the old collet from its arbor using a spirit lamp. Then I turn away the riveted section of the collet to liberate the wheel from the old mounting. To make a new collet, I turn and drill a piece of cast brass slightly oversized, using the old collet as a kind of pattern. With the new collet soldered in place on the arbor, I then begin to turn the seat concentric using watchmaker's lathe and a graver. Once the wheel is fitted onto the seat, I can then rivet it in place and finally tidy up the rest of the collet again using the watchmaker's graver. So during this re-colleting process, I noticed that 2 teeth had been let in on the third wheel, which was why it had been refinished on its faces. And I didn't really think much about it because this is quite a common repair. But when I assembled the train, I realised one of those teeth, in fact, had been too narrow or not quite in the right place, and had been faced with soft solder which had gotten the clock running for a very short period of time, but then of course as that had worn it had stopped the clock. So I replaced that tooth, and this time, in order not to do any more refinishing, I just left the tooth very slightly long at either side of the wheel face. So with the trains checked for depthing, I turned my attention to the escapement. In order to see the action of the escapement better, I set the depthing tool at the center distance for the escape wheel to pallet arbor, and then we can observe the action of the escapement outside the clock frame. Now we can see that both what we call internal and external drop are on the excessive side. So this is the free rotation of the escape wheel and the rest of the train between phases of recoil and impulse, and it would probably work as it was, but I decided to reface both pallet faces. So without taking the pallet faces back anymore, they've already been probably bent a little bit, and we can see evidence of previous interventions with the rounding with abrasive paper, and there's a running crack in the exit pallet. So I use a piece of hardened steel. I'm going to use old mainspring here. You could use something like gauge plate or ground flat stock, and so I trial fit the pieces of mainspring, making them slightly oversized, and then harden them dead hard and leave them dead hard, finishing them with diamond files and a Degussit stone to bring them down to final size, and testing that in the clock frame. Our next repair is one of the Fusee stop iron blocks. Now you can see that the block has cracked along the line of its retaining hole. Now it may be that this would be sound enough as it is, but I decided to make a repair as a failure of the stopwork is potentially dangerous. And if I were to saw this crack to allow solder to enter it, solder would actually flow into the retaining pin hole and flood it. So what I do is I ream out the hole a bit and put in a pipe, a brass pipe, which will keep the solder out of the joint. As we move towards the under dial work, I noticed the trip repeating lever, a device which allows the owner of the clock, if you like, to sound the quarter and hour striking at will by pulling a cord that's on the outside of the clock. Well, that lever had, for some reason, I don't know what it was, had been cut down, so it would only work once when the clock had been assembled, but then not again. You'd have to take the hands and dial off to reset it. So I couldn't really figure it out, but what I did was just to add a piece of steel to the end of the lever where it had been cut and filed it to shape, which reinstated the trip repeating. So we've got almost all the repairs done to the main clock movement, and so I turn my attention to the dial and hands. The minute hand collet, which is a washer essentially that keeps the minute hand flat and the clutch spring in tension, has been sort of repaired or made thicker by adding a layer of soft solder to the back. Now again, arguably this was a functional repair, but I felt I wanted the hand to be a bit more stable, so I decided to make a new undercut hand collet and tarnish it down a bit. So I just use a modern brass bit of CZ131, I think, and shape it in the watchmaker's lathe using a graver. As we move towards the cleaning process, I like, wherever possible, to disassemble sub-assemblies, such as this hour wheel slip washer that acts as a clutch so you can set the hour hand independently when first setting up the clock. But the pin had been cut flush and maybe riveted as well, which meant that this sub-assembly hadn't in fact been disassembled for cleaning in quite some time. And because the pin is small diameter, or small for a clock anyway, probably about 0.6 of a millimetre, it's a bit difficult to drill it out without the drill wandering into the brass. So I decided to shear the pin off, which is just soft iron, with a shaped piece of plastic, or in this case it's actually a piece of bone that's been filed to shape. So on to cleaning. I manually clean most clocks in paraffin, kerosene, or a proprietary oil-based equivalent. I wash and rinse, brushing with a number 2 Glasgow brush and other natural bristle brushes, and cleaning out the bearing holes with pegwood. Once the clock is cleaned and dried, I reassemble it using Moebius lubricants, primarily D3 and D5 oils in the bearing holes. There's a link in the description below, and a liquid spray grease on the mainsprings, again a link below. So there we are. We bring this project to an end. As you can see, there have been multiple and overlapping issues with this clock, and some of them arguably aren't fully resolved. We've already spent a significant amount of time and energy on it, but I think we've got it to a point where it's safe to run for the clock itself and for the person that's going to wind it, etc., and it's going to be reasonably reliable. It's 250 years old or something like that. So we kind of have to have realistic expectations about what we're going to get out of this thing, and we have to make a judgment call as to how much we do and, importantly, where we draw the line on repairs and interventions. Anyway, I'm sure you've got lots of comments to make, so I look forward to reading them below. Please remember to like and subscribe, and we will see you very soon with a new project. So, bye for now.